faculty, staff, and students, this important ritual, marking the beginning and promise and potential of an academic year at St. Andrews. Today marks the 14th anniversary of the September 11, 2001 attacks on America. And we here at the school join citizens in New York City, in Washington, D.C., and in Shanksville, Pennsylvania. We gather today to remember the heroism, courage, and sacrifice expressed on that terrible day. And as we begin this ceremony, I ask all of us to join in a moment of silence, honoring and mourning all those who died that day, and in particular, St. Andrew's own Robert Jordan, class of 1986. Convocation brings us together each year to reflect on the grace and majesty of St. Andrew's form of teaching and learning. As the school has moved through various phases of its life, our commitment to academic excellence has never wavered, but our teaching strategies and approaches to learning continue to evolve to meet the needs of a new generation of students from all across the world and all across the country, and to respond to new research on exemplary learning, and to incorporate the power of technology, and to define a new definition of understanding. One of the architects of the St. Andrews exploration of teaching and learning is our speaker today, Math Chair Eric Finch. Eric is a 1992 graduate of the College of William and Mary, where he majored in economics and philosophy, and minored in mathematics and physics and chemistry. In 2000, Eric earned his ABD degree in economics at the University of North Carolina at Chapel Hill. His teaching career has included adjunct faculty positions at North Carolina State University and Georgetown University. He has taught math and science at West Nottingham, math at Georgetown Prep, and he chaired the math department at St. Paul's School in Maryland. In September 2006, Eric joined the St. Andrews faculty, and for the past 6 years is chair of math department. In addition to teaching the first economics class in the school's history, Eric and his colleagues in the math department have created a curriculum and a teaching approach designed to build student engagement, student confidence, student understanding, and student creativity. In a recent essay, Eric wrote, "I want to facilitate the process of student learning through student action. I want to present them with challenging problems that force them to push their own thinking. I want them to be excited about their own ability to think creatively, and I want a classroom that is all about doing math." For years, his students have written powerful and inspiring reflections about their experience in Eric's classes. Here are two excerpts from members of the class of 2015. The class that profoundly affected me the most in my career at St. Andrews was economics with Mr. Finch. This was the most challenging, but more importantly, the most interesting class I've ever taken here. This course was a struggle for me, but a class I wanted to overcome and be successful in. Mr. Finch was a great teacher and made sure studying this field in college would be a good choice. And another student writing last year, "He taught me the most that I've ever learned in a math class at St. Andrews, but maybe that's because he taught me skills that I could only ever learn once. He taught me to problem solve and seek new ways of teaching and learning. Mr. Finch was an inspiring teacher in the ways he kept pushing me to rethink my preconceived notions of how good I was at math and to apply concepts that had previously seemed abstract." Eric has honored his mentor and friend, John Higgins, by building a math department characterized by collegiality, creativity, and generosity. Eric's friendship with John Higgins and his understanding of John's greatest hopes for St. Andrews colleagues in the department describe Eric this way. Kelly Lazar, Eric is a mentor, a father, and you just know he truly cares and is willing to drop anything to listen and support and guide. And Dave DeSalvo, Eric Finch leads by providing the time, resources, and professional guidance that teachers in the department want and need. He comes to life when talking about math, sharing ideas about best teaching practices, and working with us as team leaders in our math classrooms. As St. Andrews continues to dominate math team competition year after year in Delaware, as Eric shares his commitment to residential life on All West, as Eric parents his two wonderful sons, as he coaches squash or tennis, Eric Finch helps make St. Andrews thrive and develop and flourish. It's an honor to welcome Eric Finch as our 2015 Convocation speaker. Welcome.
It's been a year since Mr. Roach invited me to give this convocation address. At the time, I was humbled and honored. But for the last 11 months, I've been haunted by the scheduling of this moment. Let's think about it for a second. Most of you have been on campus for 5 days. Many of you have been here even longer for leadership orientation and sports camps, which means you were exhausted even before everyone else showed up on Sunday. You moved everything into your room, met hundreds of new people, and then perspired your way through the square dance. The next day was spent on orientation activities. That same evening, you got to do some homework and then start classes on Tuesday. You proceeded to meet your teachers and get to know your classmates, probably receiving even more homework. Since then, you've had 3 more days of classes, Wednesday chapel, afternoon practices, and I imagine staying up late and reconnecting with old friends or making new ones. To top it off, everyone just ate a big lunch. There's a good chance you have never been more tired than you are at this very moment. And this is the time that I'm supposed to talk at you for an hour in a dark, quiet, relaxing theater. Thanks again for the honor, Mr. Mayor. Since I know I am not that gifted of a speaker, we're going to do things a little differently. Just as students in my class must be active participants, I'm going to ask the same of you today. The game you're going to play is called Race to 20. The person whose first name comes first alphabetically will start. Starting at 0, the first player adds 1, 2, or 3 to 0. Players then take turns, adding 1, 2, or 3 to the previously stated number. The winner is the person who says 20. To make sure you understand, Brookie and Neva will demonstrate, with Brookie obviously starting before Neva. Ladies?
3, 6, 9, 12. 14. 16.
Nice job, Neva. So now, everyone please stand up and quickly pair up with a person near you. to winning this game. To take home the inaugural Grand Champion Race to 20, but it's not me. It's him. So Bill will start. Nice and loud. Big win. Convocation and can play him when he goes first. If you beat him, you get to take the trophy. Okay?
Oh.
Thank you, Tim. That was some nice math from everyone. In fact, figuring out how to win a race to 20 is much more mathematical than solving this. And I'd like to spend a few minutes this afternoon trying to explain why. In the 20th century, the ability to solve such problems as this could lead to a decent job or even save the world from fascism. The women in this picture spent World War II cranking out the computations needed to create the firing tables that were used on the front lines in Europe. Here's how we can solve those and much more complex problems today. Brianna is going to demonstrate an app called Photo App. math both solves the problem and explains each of the steps required to do so. The price of obtaining this app is less than a cup of coffee at Starbucks. Most students get really excited when they first discover Figure Math. They start dreaming of all the free time they'll have now that an iPhone can do their math homework in a matter of seconds. They also realize they don't need to pay attention in math class anymore. And they're absolutely right. If they were in a 20th century math class. Sadly for them, the 20th century is over, and this technology makes the simple possession of these skills obsolete. Students today are forced to work harder and think much more deeply. I was able to memorize some algorithms and practice their use on countless problems in order to prove myself as a capable 20th century mathematician. That isn't enough anymore, which is why I love teaching math in the 21st century and regularly watching my students surpass me as a mathematician. Let me give you an example. Last year I presented this problem to my class. Given that the tangent of theta equals 2.4, find the values of the sine of theta and the cosine of theta. Here was my solution that I'd worked out before class. Notice I memorized that the sine of the cosine equals tangent. I could then solve that for the sine of theta. I'd also memorize that the sine squared plus the cosine squared equals 1, a classic trigonometric identity. Knowing that the sine of theta equals 2.4 times the cosine of theta, I plug that in for sine. And remembering that I've got to square both of those terms to get 2.4 squared, which is 5.76 times cosine squared theta, plus the cosine squared theta. Here, thankfully, I realized I could either factor out the cosine squared theta, or I could add those terms together and get cosine squared theta times 6.76 equals 1. I knew enough to divide both sides by 6.76, and I had the cosine squared equal 1 divided by 6.76. Being a savvy mathematician I was, I took the square root of both sides and got my solution for cosine of theta equals the square root of 1 over 6.76. Plugged that in my calculator, it's approximately 0.39. As I had this equation for sine up here, I could plug that back in and find out that the sine of theta is 0.92. You hold your applause to the end. For that is a pretty solid representation of many years of my study. Floyd Kraut, my own high school calculus teacher, would have been proud. I was proud of myself. But then this happened. Seal?
Alright, so if you don't want to waste your time with algebra, you can just remember what trigonometry really is. And that's just figuring out what the unit circle is. And if you're like me and you know that tangent is actually just the slope of the line, you can plug this in and know that the sine and the cosine are just the coordinates of where the intersects. Figure it out in 10 seconds.
Thanks again, Sue. It still stings a little. To be honest, if I could unlearn all of the math that I currently know and start over with problem solving, I would do it. My brain is wired the same way as those women creating the firing tables in World War II. It has been trained to look for ways to plug numbers into formulas it has memorized. It works, but it isn't really math. Seal's method demonstrates the essence of mathematical thinking. He used big ideas like the unit circle and slope to understand the question in a much richer way. He could therefore see the solution in his mind and knew why it was an interesting question. St. Andrews students are thoughtful about math in a way that previous generations rarely were. This is the habit of mind that will serve them well in a rapidly changing global economy. A spate of recent stories in the media points to the urgent need for such thinking. If you've watched the news for at least 30 minutes in the last 6 months, you've probably heard a story about the march of robots into the labor market. Though our economy has rebounded nicely from the recent Great Recession, it has been marked by jobless growth, which means we have been producing more stuff, more goods and services, but we've done it without hiring more workers. Many economists believe that's because the computerization of the labor market is advancing at an unprecedented pace. This story isn't new. A recent piece on NPR's Planet Money detailed the history. The Luddites were 19th century English textile workers who fought against and tried to destroy the power looms that threatened their livelihood. You may also remember the folk tale of John Henry. He raced a machine in rural West Virginia to dig a tunnel through the mountains for the railroad. Though he won the race, his heart failed and he died. In the 1980s, machines replaced auto workers. In the 1990s, Travelocity supplanted travel agents. In the next decade, autonomous cars may well eradicate taxi and truck drivers. In 2013, two professors at Oxford University, Carl Fry and Michael Osborne, published a paper entitled "The Future of Employment: How Susceptible Are Jobs to Computerization?" They studied 9 characteristics that they expected to have an effect on a job's susceptibility to computerization. The 4 that were most significant were: do you need to come up with clever solutions? Are you required to personally help others? Does your job require negotiation? Does your job require you to squeeze into small spaces? An occupation that answers yes to the first 3 and no to the last one should still exist in 10 years. The authors analyzed 702 different jobs and found that 47% of total U.S. employment is at high risk of being computerized in the next decade or 2. I assume I haven't just crushed your dreams of being a weaver, tunnel digger, auto worker, travel agent, or taxi driver. You've probably set your sights higher, perhaps as a mathematical technician, which is someone who spends their time solving problems like the quadratic I presented earlier. Even though I obviously know about photomath, I was still shocked to learn that the Oxford study ranks mathematical technician as the 699th job out of 702. There is a 99% chance that such skilled workers will be replaced. Maybe that just means you should concentrate more in English classes. Sadly, there's an 89% chance that technical writers will be replaced in the next 20 years. I have a good friend who currently earns 6 figures as a technical writer for Cisco. Thankfully, he's of retirement age and won't be around as his colleagues lose their lucrative jobs. A firm in North Carolina called Automated Insights has a platform called Wordsmith that takes data and turns it into a story. NPR set up a contest between the computer and one of its best reporters, Scott Horsley. Here are the results. The computer wrote the slide on the left in 2 minutes, and the human wrote the slide on the right in 7 minutes. The computer isn't Jane Austen, but it gets the job done. One of the occupations Oxford found safest from computerization was social work. But even that has been put into doubt. The U.S. military has been working on a virtual therapist named Ellie. It was originally developed by a psychologist who noticed one of his patients had an easier time relating to his Game Boy than he did to his therapist. Ellie specializes in helping people with depression or post-traumatic stress disorder. They realized that much of Ellie's effectiveness was in asking the right questions and then simply listening. Soldiers in particular found it easier to talk to Ellie, because actual therapists usually reacted badly to their traumatic stories from combat, a reaction patients tended to avoid by not telling the stories they needed to share. Ellie also collects data on smiles and other micro-expressions that can indicate a patient's true feelings. That data is used to fine-tune Ellie's follow-up questions. In multiple studies, Ellie was found to be as good or better than human psychologists at diagnosing PTSD and depression. Though I don't think Ms. Roz needs to be worried just yet, Ellie is another example the rapidly growing ability of computers. On the bright side, there's only a 4% chance of authors being replaced, which is why you should make the most of your English classes. As you know, English classes at St. Andrews do more than teach you how to write a grammatically correct sentence, the way Wordsmith already can. They are not preparing you to be just a technical writer. They push you to generate your own ideas, carefully analyze texts, and generate your own original arguments. I know that it's hard work, but it produces the authentic skills that will be required for you to survive in the global marketplace you'll experience from 2023 until 2065. None of us can predict the state of the world 5 to 8 years from now when you graduate from college, let alone 30 years from now when you're in the middle of your career. What we do know is that problem solving, creativity, and social skills are the most difficult ones for a computer or robot to emulate. Those are the precise skills that you must work to hone in yourselves. That is why you are at St. Andrews, and why St. Andrews will still be here for your children and grandchildren. I was relieved to find that the Oxford paper put the odds of high school teachers being replaced in the next 20 years at only 0.8%. But that will be true only if the nature of high school teaching continues to progress and develop at a pace much faster than it has over the last few hundred years. Lectures are still a mainstay in many American classrooms. Just 20 years ago, I had a professor in graduate school who spent the first 15 minutes of each class writing theorems on the board, which he had copied out of our textbook. He was dutifully carrying on the tradition of teaching that originated in medieval Europe at Cambridge and Oxford. At the time, books were still rare and precious commodities. The store of human knowledge was found in these books. Universities were the owners of the books. Knowledge was then disseminated by having a teacher read the book to a room full of students who carefully made their own versions of the book in their notes. At Chapel Hill, I taught what were termed recitation sections to groups of students taking Econ 101. The term recitation comes from a fairly recent educational practice of reciting. Teachers would state phrases like, pistis kai episte me, and the class would repeat it back in unison. Pistis kai episte me. They would recite it. This would go on for an entire class as a way of passing along knowledge to students. There's even a scene in Dead Poets Society where a class is being taught via recitation.
Agricola, 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 agricolis, agricolas, agricolis. Again, please, agricola.
Books have been ubiquitous for quite a while now, yet too many classrooms are still dominated by a teacher reading their lecture notes. But the information age we now live in is finally making the lecture the relic of the Middle Ages that it should be. Thanks to Google and our new campus Wi-Fi, you essentially have the contents of every book ever written in your pocket. Yet now, even more recent teaching methods are under attack.
Agricola.
This summer, I had the opportunity to explore the joint venture between MIT and Harvard named edX. Thanks to Mr. Miller encouraging me, Mr. Mastrocola, and Mr. DeSalvo to enroll in a baseball statistics course, I've gotten to know the edX platform quite well, and I love it. A few weeks ago, I spent 13 consecutive hours in my dining room working on the course because I couldn't pull myself away. I even skipped lunch because I didn't want to stop learning. To be honest, as soon as I'm finished here, I may skip my econ class and head back to my dining room with my laptop because the final exam was released at 11 o'clock this morning, and I can't wait to take it. I'm just worried that Mr. Mastrocola and Mr. DeSalvo skipped this talk to get a head start on me. I'm addicted to the course because it's interactive. It gives me immediate feedback about my progress, I can work on it whenever I want to, even if that's for 13 hours one day in the middle of August. edX is also featured in Kevin Carey's new book, The End of College. After reading Carey's work, I doubt my 9-year-old will attend the type of college that I did, and you will. I think his opportunities will be better and significantly less expensive. I haven't spent his college savings on a new sailboat yet, but I may soon. Just don't tell him about it. That'll be our little secret. I like to think that 10 years ago I was teaching excellent courses in calculus, geometry, algebra, and economics. Those courses were worth the tuition. The 150 students in my course at Georgetown combined to pay $450,000 in tuition for my class alone. At the time, that was their best option. Today it isn't. If the goal of education is simply learning how to solve an equation, integrate a function, or know the 7 steps involved in implementing monetary policy, then colleges like Georgetown and high schools like St. Andrews are in trouble. The efficiency of online learning is growing at an exponential pace, largely thanks to the artificial intelligence and advancements in cognitive science that the best online courses are utilizing. The ability to target learning to the needs of individual students means that everyone will soon have access to their own personal Aristotle, just as Alexander the Great did. To be brutally honest, I could not teach the same classes I did just 10 years ago in good conscience. edX can teach you to solve equations and integrate functions much better than I can in a classroom with 11 other students. My role as a teacher must be fundamentally different today. The St. Andrews of the 21st century must be unrecognizable to students who are here in the 20th century. Though this is a significant challenge, it is also an amazing opportunity. We must leverage the fruits of the information age in order to focus more on those skills that will enable you to enter occupations that computers cannot make redundant. Again, we must work toward these: generating clever solutions, personally helping others, and negotiating with others. These skills are certainly on display in the following clip from the film Apollo 13, which I hope reminds you of your own math classroom. I call this an Alex the Astronaut problem.
Gene, we have a situation growing with carbon dioxide.
We have a CO2 filter for all the lunar module.
5 filters on the land.
We permit for 2 guys for a day and a half. So I told the doctor,
You're already up to 8 on the gauges. Anything over 15, you get impaired judgment, blackouts, the beginnings of brain asphyxia.
what about the scrubbers on the command module? They take square cartridges.
The ones on the land are round.
Tell me this isn't a government operation.
It just isn't a contingency we remotely looked at.
Those CO2 levels are going to be getting toxic.
Well, I suggest you gentlemen invent a way to put a square peg in a round hole.
Okay, people, listen up. People upstairs handed us this one, and we gotta come through. We gotta find a way to make this fit into the hole for this. Using nothing but that. Let's get it organized.
Those NASA engineers were faced with a problem they hadn't even imagined. No one knew the answer, but they worked together and found a way to bring the Apollo 13 crew home safely. I know your math teachers strive to give you the same experience and help you to hone these critical skills. They refuse to directly answer your questions, insisting you work towards your own clever solution. They require you to work closely with and help one another, either in small groups during class, at evening help sessions, or in the dorm after study hall. They encourage you to find ways to work productively with all types of students. They foster resilience by embracing your mistakes and helping you to learn from them. They train you to break seemingly impossible problems into smaller, more manageable chunks. In a recent study, a psychology professor from UCLA named Jim Stigler gave an impossible math problem to first graders in the US and Japan. On average, American first graders gave up after 30 seconds, saying, We haven't had this yet. Japanese students typically spent the entire hour and had to be told to stop. He concludes that Asian cultures typically view academic struggle as a sign of strength and a natural part of learning. They have a better understanding of a growth mindset in which one's abilities expand as you struggle and are not fixed by some genetic code. American students have typically viewed struggle as a sign of diminished intelligence and thus avoid it. You cannot simply look at the next page of problems in your math book and walk away with the defense that no one has taught you how to do that exact problem before. We don't expect you to know all of the answers, but we do expect you to think deeply about the questions. I also know that these habits of mind are being taught throughout the classrooms of St. Andrews. Mr. Porter certainly doesn't just tell you what Fitzgerald means in the last line of The Great Gatsby, when Nick says, "We are boats against the current, borne back ceaselessly into the past." Dr. O'Connor exposes you to expanding liquids, but then gives you a chance to figure out how a thermometer works on your own. Instead of simply memorizing facts about history, Ms. Presman lets you uncover the rationale behind the Declaration of Independence by reading it and other pertinent documents yourself. It is not our mission to simply pour into your brain the store of knowledge that is already available on the phone in your pocket. At St. Andrews, you are given the opportunity to unlock the wonders of our disciplines and make them your own. What we push you to do here is not easy, but it is more vital than ever to your own future and that of our society. Though I've taught classes around the Harkness Table for some time now, spending a week at Exeter this summer, where the Harkness Table was first introduced, gave me a deeper understanding of and appreciation for the philosophy of learning behind the Harkness Table. The demands it places on students to engage with their own learning are significant. Sharing your own interpretation of Toni Morrison or struggling through an Alex the Geologist problem in front of your peers can be scary. I felt that same fear as I was tackling Math 4 problems in front of other teachers at Exeter. It is easy to let our need to appear smart trump our desire to learn. I had no understanding of the growth mindset when I was in high school. So it wasn't until graduate school that I learned the importance of asking sincere questions. The Harkness Table at St. Andrews encourages you to break free from such inhibitions and begin a life of sincere curiosity and realization today. edX and online learning pose another challenge to the traditional high school, even exemplary ones like St. Andrews. The college admissions process is what economists call a problem of asymmetric information. Information about your ability as a student is not perfectly shared between you and the admissions office. Hence, it is not symmetric. College admissions officers try to close that gap by looking at your SAT scores, grades, transcript, essays, and recommendations. You have an even bigger advantage because St. Andrews has traditionally graduated students who have been successful in college. And Mr. Gilhane works hard to make sure those colleges know that. Each year, we also invite a cadre of admissions officers to campus for a few days to ensure they do know about St. Andrews and its ability to prepare you for further studies. Your attendance at St. Andrews makes it easier for colleges to recognize your potential. A century ago, prep schools like Exeter and Lawrenceville were the primary ways for Harvard and Princeton to screen students. Attendance at an elite prep school essentially guaranteed your admission to a top-tier college. Do you think that's because those students were the most deserving and capable students in the world? I doubt it. But at the time, it was the best mechanism available to Harvard and Princeton. But the ability of college admissions officers to find the best students is rapidly expanding beyond just knowing where you went to high school. We are nearing an age when colleges will be able to locate the best students and invite them to campus, instead of just hoping the best students send them an application. For example, one of the best edX courses is taught by MIT's Eric Landon, the scientist who headed the Human Genome Project. It contains the same level of rigor as the actual course taught on campus in Cambridge. When Professor Lander was asked what he found most surprising about teaching the online course, he said, "I was struck by how many really good 13-year-olds are out there." The very first edX course was in circuits and electronics. The exam for the course was purposefully MIT hard. Though tens of thousands of students took the exam, only a few hundred earned a perfect score. MIT discovered that one of those scores belonged to Batushig Myangan Bayar, a 15-year-old boy living in Ulaanbaatar, Mongolia. Where do you think he was living 1 year later? He was in Cambridge, Massachusetts on a full scholarship as a freshman at MIT. Since the results of online learning will be machine readable, colleges will soon be able to Google the best potential applicants in the world, which may or may not be the best news for you. In order to help you compete with the emerging Batushigs of the world, St. Andrews must and does offer more than the simple dissemination of knowledge. I'm looking at your faces, I think it's time for another activity. I really can't believe I'm saying this, but please take out your phone or laptop. I've enlisted Mr. Burke's help to gather some data from you using an activity that was recently posted on the New York Times website. You're going to pick an integer from 0 to 100, with that number representing your best guess of 1/2 of the average of all the numbers chosen by the members of the audience. For example, if the average of all numbers chosen was 60, then you will win by entering 30, which is half of 60. The instructions will also be on this website that you can now enter into your phone or laptop. Make sure you think about this for a second before entering your guess. As Mr. Berg told me, this is the most technologically advanced talk we've ever given in St. Andrews. I'm equivalent. So what Mr. Burke has collected is the data of all of your answers. I'm going to collate it for us so it'll make a little more sense. If you have input your data, this is our opportunity to show that we can responsibly handle this new privilege of Wi-Fi and put your phone and your laptop away.
Phone away.
While Mr. Burke collates the data, I have another question for you. Please raise your hand if your answer to the question was 0. If so, I'm tempted to waive the stringent prerequisites for my econ class, where 0 is the theoretically correct answer. 25 of you did reach that conclusion, but don't feel bad. Only about 5% of New York Times readers also recognize the correct solution. It turns out that zero is the only Nash equilibrium for this problem, a game theory concept that earned John Nash the Nobel Prize in Economics. Game theory is used to explain everything from the Cold War to competition between firms and even Jane Austen novels. Let me explain in the context of our little survey. If you thought everyone's guess would be random, then the average would be 50. And you would answer 25. But if you realize that everyone should think the same, then the group average would be 25. So you should take half of that and respond with 12.5. But then the group average is 12.5, thus forcing you to revise your answer to 6 1/4. But at this point, your logical train of thought should lead you to 0. When everyone says 0, there is no incentive for anyone to deviate. You have reached the Nash equilibrium. Notice that simply averaging the numbers between 0 and 100 isn't sufficient for this problem, nor is guessing that the answer is something less than 50. It requires you to think beyond an initial effect and consider the secondary and tertiary consequences. This is the type of mathematical thinking we ask you to do at St. Andrews. Finally, I'd like to recognize the most important teachers at St. Andrews. Though my colleagues are amazing and dedicated professionals who pour their blood, sweat, and tears into this institution, I am not talking to them. I am talking to you, Sarah Pinto. And to you, Rishi Shaw. And to you, Donovan Simpson. And to you, Diana Jordan. And to you, Robin Zhang. And all of your peers. In the face of exceptional online learning like edX, I often question the value of St. Andrews and my own role as a teacher. I've come to realize that my purpose is no longer showing you how to do math problems. My purpose is doing math problems with you and analyzing how you are thinking about those math problems. My purpose is to challenge you with tasks that are difficult but achievable with sincere effort. My purpose is creating a learning community where you have the opportunity to think creatively, work collaboratively, and help each other. For those are the attributes that will serve you well in your professional and personal lives throughout the 21st century. But you cannot collaborate and help others in isolation. You need your peers to reach those critical goals. None of them can be achieved sitting in front of your laptop. St. Andrews brings together some of the most curious and engaged teenagers in the world. That is the beauty of this place. Not the pond, not the buildings, not even the incredible faculty. You, the students around you, and the students yet to arrive will ensure St. Andrews remains a thriving community of faith and learning. Thank you.